Welcome to Brain Vision.
In this question, we want to find the appropriate equation 8.2, the conservation of energy equation, okay, for four different situations, okay. So our conservation of energy equation, okay, this is delta K plus delta U plus delta E internal is equal to work plus heat plus the transfer of energy through mechanical waves plus the transfer of energy through matter transfer plus the transfer of energy through electrical transmission plus the energy transfer from electromagnetic radiation. Okay, so just write down what each subscript means. Then ET, electrical transmission. And ER is electromagnetic radiation. Okay, so there are four parts. In part A, the situation is the heating coils of after you switch on and in the first 5 minutes. Okay, so in the first 5 minutes, assume that you did not move. Okay, so delta K will be 0, delta U will be 0. So the left hand side, you are only left with delta E internal. Okay, because that's for the heating coil. Okay, and the heating coil is not moving. Yeah, and then we have the energy will be heat given out plus energy transferred through electrical transmission, okay, plus the electromagnetic radiation. Okay, so yeah, so this Q is heat given out by toaster. Okay, and then the TER is the electrical energy taken in by toaster. Okay, and then TER is when the heating coil grows. Okay, so there's light energy. Okay, right, in part B, the situation is your automobile from just before you fill it with gasoline and until you pull away, until you drive away from the gas station with speed V. Okay, so there's an associated change in kinetic energy, potential energy, in particular chemical potential energy, and then E internal is equal to the work plus Q plus TMW plus TMT. Okay, so what happens is that so TMT is mass transfer, in particular fuel from uh, from the just energy from the fuel. Yeah, okay, and then the delta U is chemical potential energy. Yeah, so I just want to make the TMT clearer. it's not quite like energy from fuel, but that's actually the chemical potential energy. It's like filling up of fuel. Yeah. Then during the driving, so delta K increases, driving K. Then there is heat. Yeah, so work is done in the engine. Work is done by gas in engine. Okay, Q is the heat release from engine. And then the TMT, MW, sorry, is sound waves. Okay, sound waves from engine and plus motion. Okay, yeah. So in part C, what happens is that the system is the body, and then you are eating peanut butter jelly sandwich. Okay, so the equation is delta E or delta U. Okay, delta U is equal to Q plus TMT. Okay, so delta U is the chemical potential energy from the food. You kind of increase that, and Q is the heat release by body, and then the TMT is the take in energy from food. Okay, yeah. Then in part D, yeah, just to box up the answers. Okay, okay. In part D, the system is home. 5 minutes under sunny afternoon, and the temperature remains constant. Okay, so the equation is 0 equals to Q plus TMT plus TET plus TER. Okay, so the left hand side is equal to 0 because the house is at constant temperature. Yeah, there's no delta K, there's no delta U because the house is not moving, not changing heights or position. Okay, delta E internal is 0 because the house is at constant temperature. Okay, so the Q is the heat release by air conditioner. Okay, and then the TMT is the mass transfer. So the mass transfer of warmer air, okay, in the air conditioner. Okay, and then the TET is the electrical transmission. So electrical energy to the air conditioner. And then the TER is the radiation from the sun. Okay, so this is how we arrive at this equation. Okay, and that's all for this question.